We are not doing a TikTok. All right, so here we go. Lesson 2-3 for our pseudo BC calculus class. Today's date is Wednesday, March 4th, 3/4, 2020. Our objective today is to do what, Fiona? Yes, thank you. Sorry, Chris. Next time. So there are 3 formulas that you have to have memorized by the end of the day. That's on the back half. Those are the 3 formulas that you will memorize. On the front half, you should know how to do inverse trig functions. And they're hard if you don't have your unit circle memorized. Give me a fist of 5. How well have you memorized your unit circle in terms of radians, degrees, where the square root of 3/2 is, all that stuff? Give me a fist of 5. I'm seeing 1s, 3s, 2s, 1s, 2s, 2s, 1s. Flip me off and a 3. Okay, so.
Why the fuck you guys all look at me? Wow.
Yeah, so that means today's lesson is going to be harder than if I was at a 4 or a 5 out of 5 on my unit circle. I am currently at, I would say, like a 4, maybe a 5 on a good day. So I will be able to do this lesson a little bit easier. So what is an inverse trig function? Do you remember all the way back to geometry? And we just did this lesson like a week ago in geometry where I said, hey, sine is equal to 1. I need to solve for theta. What do we do to both sides to undo sine? You guys remember how to do this with a quiet raised hand? How do we undo sine? That's some geometry.
What do you think?
Huh?
Is there a quiet raised hand out there that wants to ask me what I think? Chris. I think that it's going to be arc sine. Yeah, so you can write that one of 2 ways. On the calculator, because calculator keys need to be nice and short, they cannot say arc sine. They say sine to the -1 because it saves a little bit of space, but you guys can write arc sine. I'm going to be writing arc cosine because it's easier to read. I'm going to take the arc sine of both sides. So arc sine of the left side, arc sine of the right side of the equal sign. And I should turn the music off also. So this will undo sine. And we saw yesterday the definition of a function and its inverse. When I do the inverse function of the function, I'm left with theta. Just like if I did f of g of x is equal to x, this is kind of the same thing. Arc sine of theta is equal to sine. Equal to theta. There. The way that we notate that is we say, yes, the arc sine and sine cancel out, and I'm left with theta. This sign was just talking about that part right there. Don't think of it as arc sine of theta. So just theta now is equal to arc sine of 1. And then in geometry, we said, okay, good enough, done. Plug that into the calculator, and we get our answer. For you guys now, I'm going up to the next level. Here's the next level. What is arc sine of 1? You can do this in your heads now. What is arc sine even asking you? And you haven't seen this before, so let me help you out. Arc sine of 1 is asking me, if I take the sine of an angle, I'll get 1. Yeah, I moved it. I'll tell her later. This is asking, since it's sine, this is asking for the y coordinate. Okay, thank you, Kat. Go away. Okay, this is the y coordinate. Y coordinate. Where do I have a y coordinate of 1? Done. You just found the answer. Theta is equal to pi over 2. Theta is equal to pi over 2. So, if I ask you a question, arc sine of 1, you will respond pi over 2. You want to try another one?
Sure.
Let's do like a fist 5 on just understanding how I got the pi over 2. This is a quick verbal. Okay, nice. So we understand that. Let's move on to another one. Let's do arc cosine of -1/2. It's slightly harder. Arc cosine of negative 1/2. Again, write down the question that it's asking us. Cosine, that's x or y? X. You guys all shout out x. And then, where do I have an x coordinate of negative 1/2? Okay, well that's harder to think about, so I'm going to go ahead and make like a mini unit circle. Down here, negative 1/2 is right about, so if my unit circle looks like that, right? Negative 1/2 is right about there. That's the x coordinate, negative 1/2. Oh, there's actually two answers. Check it out. There's an answer right there, and there's an answer right there. And you can go ahead and make that line. So that line looks like that, and it looks like that. Does anyone remember what angle either one of these is? Hold on, Eva got the last one. I'm going to give it to someone else with a quiet raised hand. Eva, you're killing it. Good job. Eva will correct whoever it is.
That one.
Top one?
Yeah.
Is?
Never mind. I take that. I take back.
All right, well, let me ask you, well, if I have the unit circle and I'm closer to the y-axis, I'm dividing by 3. If I'm closer to the x-axis, I'm dividing by 6. So this is closer to the y-axis. My diagram isn't quite to scale. This is closer to the y-axis, so it's something divided by 3. Something pi divided by 3.
That was like the opposite.
And Eva, say it louder. That first one is 2 pi over 3.
See, I thought it was the opposite.
So this one right here is 2 pi over 3. What about this one? This one is also closest to the y-axis, which means it's something divided by 3. Let me give you the setup there. Something pi divided by 3. Stego? 4 pi divided by 3. Is that what you agree with, Fiona? Yep. You guys both have it. You girls both have it. There's our answer. It could be either 2 pi over 3 or 4 pi over 3. And I've made an assumption here that I haven't made explicit. I'm assuming that I'm between 0 and 2 pi. Because technically, I could add on 2 pi, I could add on 4 pi, I could add on 100 pi, and it would still be the same answer. But I'm assuming between 0 and 2 pi. Let's try another one. Arc sine of the square root of 3 over 2. Okay, so again, ask the question. Sine is the, everyone shouts out the what coordinate? The y coordinate. So square root of 3 over 2, is that bigger or is that less than 1/2? Again, I'll ask the question. Is this number right here, is that bigger or is it less than 1/2? With a quiet raised hand, James. It is indeed bigger than 1/2. So I'll say bigger than 1/2. So if I'm making my unit circle for my help, I'm going to have, maybe if I make a real circle, it'll actually be to scale. I don't know why I'm not using my technology here. So if I have my unit circle, and my center's right here, on my unit circle, I need to be bigger than 1/2. Well, 1/2 in terms of the y coordinate is right about there. So more than 1/2 is right about there. Oh, look, again, I have 2 points, there and there.
Whoa.
And I can make this slightly, I'm going to make it kind of extreme. So here and here. That's still, that looks like a 45, 45, 90, so I need to be careful. Let's make it super tall up here. Here and there.
It's like pi over 6.
Not quite. So divided by 6 is going to be down here or down here. Again, it's going to be divided by 3.
Okay.
So this one is going to come out this direction and this direction. What are those two angles? Say again louder, Fiona. So pi over 3 or 2 pi over 3. Done. Again, knowing sine is asking for the y coordinate. Y equals a function. Y equals square root of 3 over 2. I'm kind of intersecting this line of y equals square root of 3 over 2 with our unit circle. And this next one is going to be even harder. So sorry. Like, you'll have lots of practice on the homework with easier ones. I'm getting harder and harder in the notes. So I'm sorry if you haven't gotten like that 4 or 5 out of 5 understanding yet. Let's try a tangent. Arctan of -1. So first of all, can you guys remind me that acronym for sine, cosine, and tangent? What does it sound like? Yeah, say it louder. SOHCAHTOA, thank you. So tangent is the opposite divided by the adjacent. So if I'm on a unit circle, I'm going to play around with some math a little bit. If I'm on my unit circle and I have a triangle, let me just randomly make a triangle out here. And I'll pause so that you can catch up. I'm writing down SOHCAHTOA. It's going to help me because I'm going to do the opposite divided by the adjacent. So I randomly decided to make a 30-degree angle here. With a 30-degree angle, let me maybe label this zoom, enhance, zoom, enhance. This is 30 degrees here. With a 30-degree angle, oh wait, we're in BC calculus. I should say pi over 6 radians, which is the same thing as 30 degrees. What are my dimensions? What is this length right here? What is the y dimension? What is the x dimension? Can someone help me out? With a quiet raised hand, if this is pi over 6, how big is that? Quiet raised hand. Who's got this? You have 5 choices. 0, 1, and it doesn't make sense. Square root of 3 over 2, square root of 2 over 2, and 1/2. One of those 5 numbers is going to be that length. One of those 5 numbers is going to be that length. Take a guess. Quiet raised hand. Otherwise, I'm going to cold call. Yes, Teflon. 1/2? It is indeed 1/2. Everyone label it. All right, so what about this length right here for the x-axis? It's one of those 5 numbers. You only have 5 choices. Andrea? It's a 30, 60, 90 triangle. Should I list all of your choices again? Yeah. You have the choice of 0, 1, square root of 3 over 2, square root of 2 over 2, and 1/2. Those are the only 5 numbers that we have for special right triangles on a unit circle. So let me see if I can zoom in so you can see everything. Andrea, take a guess. It's not 1/2, by the way, because that one's already been kind of used. It's bigger than 1/2. It is indeed square root of 3 over 2. And if you forgot those, I have my living textbook, my classroom walls on the top left of my cubbies up there. I have those dimensions up there. I think something divided by 3. Oh, maybe not. Yeah, I've been wanting to make large posters. I don't have the technology to do it unless I print them out on 4 pieces of paper and have arrow glue them together or something. Okay, so let's assume that we have a perfect understanding of, oh yeah, if I have a 30, 60, 90 triangle with a pi over 6 radian degree triangle, then that's 1/2 and square root of 3 over 2. You can get there. We assume that. So now I'm going to ask the same question. Arctangent is asking, okay, I need to undo the angle. So I'm trying to find the angle. Maybe the answer is pi over 6. If the answer is pi over 6, let's check that. Tangent is opposite divided by adjacent. Which one of these is opposite? Which one of them is adjacent? If my angle of reference is right here in the bottom left of the triangle. Which one is opposite? Which one is adjacent? Help me out. Stego.
1/2 is opposite.
Yes, label it. Everyone label O. 1/2 is our opposite. And therefore, Stego, square root of 3 over 2 is our adjacent. Which means, we're saying now, if I'm dividing, like in tangent, opposite divided by adjacent, if I say opposite, 1/2, divided by adjacent, square root of 3 over 2. Let's check what fraction that is. If it's equal to 1, if this right here is equal to -1, we have our angle. The angle is pi over 6 radians. And it's clearly not going to be 1 or -1. This is going to be equal to, keep it, and I'm going to change it, flip it eventually, square root of 3 over 2. I'm going to keep it, change it, flip it, keep it, change it, flip it, and this is, the 2's cross cancel, and this is equal to 1 over square root of 3. Well, darn, that's kind of cool though. If I had asked you what is arctan of 1 over the square root of 3, you'd say, oh, pi over 6. But unfortunately, I'm asking you for arctan of -1. So -1 means, if I kind of zoom out and look at this problem as a whole, -1 means if I divide this number by that number, or vice versa since it's -1, if I divide this one by this one, I should get -1, which means these have to be the same number, but one is negative and one is positive. What type of angle do we have where this length and this length are the same number? I'll ask the question again. When this length in terms of the x-coordinate and this length in terms of the y-coordinate are the same number, what type of triangle, what type of angle, either one of those, do I have? I see 3 hands. Fiona?
With 45.
Say it louder.
45.
We can all hear.
46.
Yeah, 45, 45, 90, which means we have what type of angle then? Someone else. It is a 45, 45, 90 triangle. So what types of angles? Give me an angle that has a 45, 45, 90 triangle. James. Yeah, well, all of them are going to be right, yeah. So you're correct. You're not incorrect. But help us a little bit more. Here, I'll draw all possible triangles that are 45, 45, 90. Ready? Here's our new unit circle. I have one coordinate right there, one coordinate right there, one coordinate right there, one coordinate right there, so that this makes a perfect line, this makes a perfect line, and there's that triangle, there's that triangle, there's that triangle, and there's that triangle. Those are our 45, 45, 90 triangles. So let's label all of them. And it's going to be a little bit tedious, and you don't have to follow along in terms of writing this down, but at least follow along mentally. I have so I need someone to help me out. What is the length of all of these in terms of, you have these 5 choices, right? Which of these 5 choices are the lengths for each and every one of them? Quiet, raise hand. Who has it? Eva, which one is it? No, square root of 3 over 2 is a 30, 60, 90. I'm doing a 45, 45, 90 now, so it's a... Say it louder. It is indeed square root of 2 over 2. So each of these is the same thing. I'm going to put tick marks and just label one of them. Each of these is the square root of 2 over 2. So the square root of 2 divided by square root of 2 is 1. But, here's the but. This one has a negative x-coordinate. This has a positive y-coordinate. So this is one of the answers. I'll say that once again. Our x-coordinate is positive. Our y-coordinate is positive. Our x-coordinate is negative. When one is negative, one is positive. That means that's -1. So this angle right here is an answer. I'll circle it. Does anyone see another answer? Where do I have a positive x and a negative y, or a negative y and a positive x? Well, going through this. This is a positive positive. This one was a negative positive, so that was an answer. That's a negative negative. No, and therefore, Andrea, it's... This one is a positive x, negative y, so that's the other answer. Circle it. And finally, can someone with a quiet raised hand tell me what those are in radians?
You're so quick.
Yeah, this is because we have that... There are very few people that even had a 3 out of 5 on that one. I'll give you a hint. This one, that don't really need, this one up here is pi over 4. This one is 2 pi over 4, aka pi over 2. This one, therefore, must be, Eva? 3 pi over 4. And what about this one down here for the final answer? This one is 8 pi over 4, and I have to subtract one of those. And Eva has it, 7 pi over 4.
Okay.
So our answer here is 3 pi over 4 or 7 pi over 4. And doing this lesson assumes that you have a 4 or a 5 understanding on all of our trigonometry up to this
I'm
point.
not even at 1.
Then we need to go back and review some.
I'm not even at 1.
And the hardest type of question that I will ever ask you on a test is arctan of square root of 3. That is the penultimate challenge. So here's another way of approaching this problem. For arctan of square root of 3, we're really asking ourselves, if I divide the opposite by the adjacent, how do I get the square root of 3? Well, I only have 5 different numbers to choose from. I can't say 0 divided by anything, because that would be 0. I can't say anything divided by 0, so I can't use 0. So I really limited it to 4 choices. Since all of these are really divided by 2, 1 is really 2 over 2, let's multiply everything by 2 in terms of the number of choices that I have. I'm allowed to do that because eventually I'm going to do 1 divided by the other. The 2's will always cancel out. So underneath each of these values, I really have 2, square root of 3, square root of 2, and 1. These 4 numbers, can you somehow divide one number by the other and get square root of 3? What divided by what is the square root of 3 only using those 4 different numbers? With a quiet raised hand.
Divided by what?
So I get to choose one of these numbers and then another of these numbers in a fraction. Something divided by something equals square root of 3. Does anyone see it? One person sees it. I need to wait for 4 hands. 2 people see it. What divided by what in here gives you square root of 3? Don't overthink it. It's as easy as I can make it now. I have 3 hands. I need 1 more hand. There's 4 hands. Arrow.
Square root of 3 divided by 1.
Square root of 3 over 1 is square root of 3. Exactly. So this is equal to the square root of 3 divided by 1. And remember, we really were multiplying everything by 2. So what I really have here is this. The square root of 3 over 2, all of that divided by 1 over 2. And as a hint, there are 2 answers to this because I could have done this. I could have said, down here, I could have said negative square root of 3 over 2, all of this divided by negative 1/2. That is the same thing because a negative divided by negative is a positive. So from here, what is an angle that gives you, again, this is always opposite over adjacent, and for tangent, opposite is always going to be the y-coordinate. So you can think about this as y-coordinate. Let's do this in red. The y-coordinate divided by the x-coordinate, or the y-coordinate over the x-coordinate. Arctangent will always give you y over x. So where do I have a y-coordinate of square root of 3 over 2 and an x-coordinate of 1/2? Graph it, right? You just graph this out, and I say, okay, well, I go x-coordinate 1/2, so about there, and then y-coordinate slightly more than that up here, and I get that point right there. What about another type? Let's try doing the x-coordinate is negative 1/2, so right about there, and then the y-coordinate is negative square root of 3 over 2, which is right about there. That point right there. Those are our answers. What are those angles? It's really close to the y-axis, so it's going to be something divided by 3. Something divided by 3. Again, if you're close to the x-axis, it's something divided by 6. So it's something divided by 3. Eva, you're the master at knowing these. Stego, I might call on you. I need more hands, though. What are these 2 angles? Stego.
The first one is pi over 3.
First one is pi over 3. What about the second one? I'll give you a hint. This is 3 pi over 3 right here.
4.
It is indeed 4 pi over 3. So our answer, coming all the way back, this is equal to, and I'll do it in red for our final answer. Our answer is pi over 3 or 4 pi over 3. I forgot the pi down there, didn't I? 4 pi over 3. 4 pi over 3. And I need to box that because it is very unclear where my work went there. And I should box my answer up here to be very clear about this.
You guys get that too.
That is half of our objective today.
Oh my god. Are you kidding me?
That is the harder half.
I only have 10 more minutes left.
So our objective is to memorize or evaluate inverse trig functions. That's how you do inverse trig functions. The homework is going to be easier than the notes. I won't ask you arctan of square root of 3 on the notes. Now the formulas that you need to memorize. I'm not going to ask you arc cosecant, arc secant, or arc secant. I'm only going to ask you these three: arc sine, arc cosine, arc tangent. Memorize them. Love them. Think about them before you go to bed at night. Notice that it's the same kind of trick. Remember, if I'm talking about sine, S stands for same. So it's the same sign. C stands for change in sign. It's the same thing with a negative. And then all I have to do for arctangent is I square the bottom. If I square the bottom, the square root disappears, and it's the same thing as these guys just squared. So you're really memorizing one formula with a little tweak for each type. Proving where these come from takes maybe 5 to 10 minutes. I didn't think it was valuable, so I'm not going to go over it. Let me show you how to use them, though. So let's assume I've memorized it. Let's apply arc sine. So I'm going to rewrite this formula, but in the place of x, I'm going to write whatever that is. And then don't forget dinner. Here we go. You're following along with me. I'm recopying down. This is now 1 over the square root of 1 minus, not x anymore, not x squared anymore, it's this thing. It used to be x squared, right? Inside x, it's now 2x to the power of 5. So this is now 2x to the power of 5. I'm not done, I'm halfway done. All I did was I plugged this into that x and make sure that you're going to square the entire function. That was doubter. What's dinner? What's dinner? 10x to the 10x to the 4. So come down here and say this is times 10x to the 4. Done. There it is. That's the answer. If you want to simplify a little bit, you can. I'll show you how to simplify because you will need to do that on my tests. Well, I'll give you a multiple choice where the answer is simplified, and it will confuse you if you don't know how to simplify. The answer here is 10x to the power of 4 in the numerator. In the denominator, I still have the square root of 1 minus something, but that something is now 4x to the power of 10. Where'd the 4 come from, Mr. Sindel? I'm squaring both parts of this term. I'm squaring the 2. 2 squared is 4. I'm squaring the x to the power of 5. This is really 5 times 2 to get 10. Let's try another one.
Yes, sir.
Arctan. You all know it's 1 over 1 plus x
I
squared.
did it in the wrong spot.
1 over 1 plus x squared. That thing squared. Therefore, this is going to be e to the power of 2x. But what do I need to multiply by now?
Dinner.
Dinner. What is dinner? Someone. Anyone. Shout them out. E house is E house, right? E to the 2x. But I have a dinner inner now. Times 2. Geo, question. Oh, you got it. Okay. And then simplifying this, in the numerator I have 2e to the 2x. In the denominator I have 1 plus e to the, okay, a power to a power. I multiply. 2 times 2x is 4x. Done. I should be boxing these.
Like this one first.
Yeah, these are the easier ones, as long as you have the formula memorized. That's all I have for you guys. All right, so there were 2 pieces to our objective today. Give me a fist of 5. How well can you, 1, evaluate inverse trig functions, and 2, use our formulas, memorize and use those formulas, I guess. I'm hoping that I get at least 1 4. I got a 3, a 2, a 3, a 2, a 1, a 2, Chris, a 0, a 3, arrow,
7.
a 3, and over here, Fiona, a 5. Whoa, nice.
That's a 3 on 2. She was
Oh,
like,
okay, I'll give you a 2. Okay.
should I just do that?